All right, good morning. This is going to be for section 7.2 in your pre-calculus book. This is on circles and ellipses. So let's get going. All right, so circles and ellipses. You've seen circles and ellipses all over the place before, and you've also dealt with circles in geometry, so that should be pretty familiar to you. So when we're dealing with circles and ellipses and all this whole chapter, I have put two papers up for you with these two links. Now, if you're in my class, you can see them on my website. But if not, you can use these links to get to these PDFs. And this is just kind of like a overview cheat sheet on conics in general. It has all the formulas. Now remember, all these things, we're not going, because we have to do this distance learning, we're not being very particular with all these things. We're not doing like a lot of the foci and the asymptotes and those kind of things when you deal with circles and ellipses, especially, ellipses and hyperbolas. We did do them with parabolas because the questions on MathSpace had those items in there, so I had to do it. But anyway, we're not being as detailed as we normally would. So here we go. So circles. So you already know basically circles from probably earlier this year and also in geometry. So the basic equation for a circle is, is x minus h squared plus y minus k squared equals r squared. So for the circle, you're going to have a center at the letter or the numbers h and k, kind of like you did for a parabola with the vertex. And remember, r is going to be your radius. So let's jump in with a couple of examples here. So let's say, for example, I was given this equation, x squared plus y squared equals 36. So in this circle right here, you see the x squared and the y squared have no numbers with them. There's no parentheses. They're squared. But this is, so basically your center here is just going to be at 0, 0 at the origin. And the radius is going to be the square root of 36. So the radius is 6. All right, so if you drew that, then you know you would be going out to 6 on each side, right at the center, so you'd have a circle right there. And if somebody asked you for the domain, you would say, hey, it's going from -6 to 6 along the x-axis. So basically the width of it is from -6 to 6, and the range is the same thing, -6 to 6. That's interval notation. MathSpace is going to ask you to do that. All right, so one thing I wanted to mention up here earlier was in this equation that you have here. I want you to notice some things about this equation because we're going to start seeing differences with these equations. Notice that in this equation, x is squared and also y is squared, whereas in our parabolas, we only had one or the other. And notice it's addition in this equation. And also notice on the other side you have it's equal to r squared. So that r squared could be a 1, it could be a 10, it could be a 20, it could be a 36. So it can be lots of things. And there are no fractions. It's supposed to be no fractions here. Now, I guess your radius over here, the r squared could be a fraction, but there's no fractions like right there or right there. Okay, so again, you're taking these notes on your own paper, or you can print them out after we're done. So I just have a couple more examples for circles, and so here we go. So for this next example, let's say you have a little more complicated. You have x plus 3 squared plus y minus 5 squared equals 10. So, you know, your center is going to be left 3 and down 5. I'm sorry, left 3 and up 5. So 3 comma 5. -3, 5. And the radius is going to be a little bit strange here because this is a 10 over there. So the radius is going to be radical 10. So remember, this right here is r squared equals 10. So if you want to solve for r, you do the square root, and there's your radius. So if you were going to draw this, you would go to -3, 5. So -3 and up 5. And then square root of 10, that's about, 3.1 or so, 3.1, 3.2. So you would go out 3 in each direction. So your circle would end up kind of looking like that big, if my drawing's not too bad. But remember, you can also put these things in Desmos. So if I just go ahead and enter that equation, x plus 3, if you ever want to get a picture of it. Oh, whoops. Sorry. going kind of slow, equals what, 10. All right, so there's that circle, and you can pick some points on there and see some points. All right, and I guess it doesn't tell you the center, but that's that. All right, and so let's go on to the next one. So in the next two problems, we're going to have to fix what's going on here. We're going to have to basically complete the square like I taught you in the last lesson. All right, so in our next page here, our next example, we're going to be given x squared minus 6x plus y squared plus 8y plus 4 equals 0. So everything's all jumbled up, all right? So what I have to do is kind of group my items first. They're already grouped a little bit here. You notice that the x's are together and the y's are together. So I'm going to have x squared minus 6x, put some parentheses around that, leave a little space, put another parentheses, plus then I have my y squared plus 8y, leave a little space, and that 4 can just go to the other side, so it becomes a negative 4. All right, so I have to complete the square. So remember, when you're completing the square, what you're going to do is take half of this middle number and square it. So half of 6 is 3, and 3 squared is 9. So I'm going to add 9 here. Well, I'm adding 9 to that side, so I have to add 9 to this side to be fair. And same thing with the 8 over here. I take half of 8, which is 4, and 4 squared is 16, so I add 16. So I have to add 16 over here. All right, so remember, the whole reason that we were doing this is because we are looking to get a perfect square when we factor. So remember that this factors into x minus 3 squared, and this one is y plus 4 squared. And now the right side, you just tally it up. It's 25 minus 4, so 21. So there we go. We have a circle with the center at 3, negative 4, and the radius is the square root of 21. So we could draw that if we needed to. All right, and then the last example here. My last example is going to be same thing as I just did, but a little bit, oh gosh, sorry. A little bit more detail, more to it. So my last example here is going to have 5x squared plus 5y squared plus 10x plus 20y plus 8 equals 0. All right, so again, I'm going to collect my pieces. I got 5x squared plus 10x, and then over here I have plus 5y squared plus 20y, and the 8 can go away to the other side. All right, so as I factor this out, I need to, these 5s out of here. So notice that they match, and so that's something that's particular with circles, and with ellipses it's going to be a little different. All right. So I'm going to take out the 5. That leaves me x squared plus 2x. Leave a little space. Divide out the 5 here. It leaves me y squared plus 4y. Leave a little space equals negative 8. All right, so I'm going to complete my square. So half of 2 with the x is 1, and 1 squared is 1. So I'm going to add 1 here. But I'm adding 1 there, but really I'm adding 5 times 1. So I'm really adding 5. So I have to take away, add 5 to this side to be fair. All right, here's my 4. So half of 4 is 2. 2 squared is 4, so add 4 here. So I'm adding 4, but I'm really adding 20, because remember that would multiply to 20, so I need to add 20 over here. All right, so let's clean this up. So I have 5, and I have x plus 1 squared, and I have 5, and I have y plus 2 squared equals, let's see, 25 over here. Oh, dang it. I wanted that to be a 9. I'm sorry. I'm going to change this up a little bit because I wanted it to come out kind of nice. So I wanted this. So change that 8 all along. Change it to a 9. So sorry about that. Because then I have 25 minus 9 on that side, and I have 16. I wanted it to come out pretty here. Yeah, 25 minus 9 is 16, right? Yep, okay, this is not going to come out pretty. All right, so let me figure out real quick. I wanted that to be, I'm sorry. Let's see. Let's just change it to a 5. All right, sorry about that. I need this to come out. So again, I'm sorry. change that to a 5, so that's going to change there. Make that a 5, which moves us over to a 5. So then I get 4. I'm sorry, then I get 20 on this side. All right, so let's divide everything. Now we have to get it in the right format. So these 5s, they can't be here. So I have to divide everything by 5. So I get x plus 1 squared plus y plus 2 squared equals 4. So there I go. I have a circle with a center at -1, -2, and my radius is 2. All right, so here we go. So now on to ellipses. So ellipses are just like ovals, basically. They're just circles that are, squished one way or the other. And so with ellipses, you have a little bit more to deal with. And so there's a definition of ellipse: the locus of points in a plane such that the sum of the distances from two fixed points, basically the foci, is constant. So like I said, we're not going to deal. So what they're telling you there is that these distances here are the same from this foci to that, and here to here, and here to here. So, but you don't really have to know all of that right now because we're not going to be too detailed. So what you do need to recognize on this picture, though, is that this ellipse, like an oval, first of all, it has a vertex. It's called a vertex. Those are the vertices on either side of the major axis. This longer axis is the major axis, and then you have what's called a minor axis. So this minor axis is right here, and those are called co-vertices at the end of that. When you get on Math Space, they're going to ask you some questions about that. So anyway, I'll go through them in the examples as well. So when you have a, an ellipse, the basic equation for ellipse is this. It's x minus h squared over a squared plus y minus k squared over b squared equals 1. So some things to notice. It has x squared, it has y squared, it has a plus sign, and it has to be equal to 1. And notice the a squared and the b squared. Now, this is going to be very simple. Whichever number is bigger under here, if a squared or b squared, whichever one's bigger, that's the direction along the x-axis or the y-axis that it's going to go for. So whichever one's bigger, that's going to be the ellipse going either long ways this way, or like kind of horizontally, or it could be like more of like a vertical type. All right, so we'll get to that in the examples, but basically the a squared and b squared are going to tell you how far to go in each direction, the x direction or the y direction. All right, so let's get to an example. All right, so, next page. So my example here, I have x minus 2 squared over 9, plus then I have y plus 5 squared over 25 equals 1. So in my example here, the center of my ellipse is 2 and -5. And notice it's going 3 because a squared is 9. So a would be 3. That means it's going 3 in the x direction from the center. And this right here, the b value is 5. So it's going 5 in each direction in the y direction. All right. So let's go ahead and draw this up. So I'm just going to do like a little sketch basically. So I have to go to 2, -5. So over 2 and down 5 would put me about like right there. And then I have to go 3 in the x direction. So let's see, 3 in the x direction. So it means I need to add 3 to that x right there. So I need to go to 5, -5. And then I need to go 3 backwards also. So 2 minus 3 would be -1, 5. So that's 3. That's 5, -5. And this one would be -1, -5. So then I have to go in the y direction 5 places. So I'm already at 2, -5. So that would be, I would be at 2, 0. All right. And then I would be at down 5 more. So I'd be at like 2, -10. Now, my picture isn't so great right here. My picture, remember I'm going longer in the y direction, so this ellipse is supposed to look elongated this way, but it's not going to look that way on my picture here. So because I didn't kind of space it out nicely. But anyway, there's my ellipse, like right there. And it looks more like a circle, but like I said, it's supposed to look more like this. So these two things, since that's the shorter thing, those would be my co-vertices. And these two red ones, those would be up here, those would be my vertices. And they're going to ask you like the length of the major axis and the length of the minor axis. So the major axis is this distance right here. So remember, we had to go 5 up and 5 down. So that would be 10 units. And the minor axis is this way. So remember, we had to go 3 right and 3 left. So that distance would be 6. Okay. All right. So the only thing we're going to run into here, one more thing. Sorry about that. They might ask you for the domain and range. So the domain, remember, look at my width of this picture. My domain goes from -1 to 5 because that's the width of my picture. So -1 to 5. And the range goes from -10 to 0 because that is the height. So this number to that number. All right, so the only other thing you run into with these is going to be if these are the equations all jumbled up. So this is our last problem. So if I had 4x squared plus y squared minus 64x minus 12y plus 276 equals 0. So again, I'm going to group things together. I got 4x squared minus 64x. Leave a little space, plus y squared minus 12y. And the 276 can go to the other side. Ugh. All right, so factor out this 4 here. So 4 leaves me x squared minus 64 divided by 4 is 16x, leave a little space, plus the y squared doesn't have anything, so y squared minus 12y, leave a little space, equals negative 276. All right, so let's complete my square. So I need to take half of this 16 right here, so that's 8. 8 squared is 64, so I need to add 64. But remember, I'm not really adding 64, I'm adding 4 times 64. So if I'm adding 4 times 64, that's 256, so I have to add 256 to this side too. So over here, half of 12 is 6. 6 squared is 36, so add 36. So that one doesn't have a number out here, so I'm just adding 36. All right, so let's tally everything up and clean this up. I got 4. This factors into x minus 8 squared. Then I have y minus 6 squared equals, and if you add all those things up, you get 16. Now, remember, the general format for this thing is going to be always equal to 1. So I have to divide my equation so that the right side becomes 1. So I need to divide everything by 16. So on the right side, 16 divided by 16 is 1. This y minus 6 part just keeps the 16. And over here, 4 and 16 reduced to 1/4. So that's going to be x minus 8 squared and then a 4. So there you go. You have your center at 8 and 6. You're going to be 2 each way in the x direction, and you're going to be 4 each way in the y direction. So that means, again, you're going to have an elongated ellipse that way. And, you have your minor axis and your major axis. You have your co-vertices right here and your vertices right there. All right, so you can see that on Desmos if you want to graph it. And that is it. I'll see you later. Bye-bye.